So we now have quite a lot of time for conversation. Before I open the floor to the room again, I would like to take the opportunity and ask to the panel, essentially, how you guys are looking into the future with all the different moving parts that we have mentioned along the day. And I'm particularly thinking of this huge diversity of standards that exist out there, and probably the need for some convergence. The dynamics of the voluntary carbon market itself, we've said that it is evolving, shifting towards probably higher quality. But at the same time, what is your take on the main drivers that drive the purchases? And also, if you have a particular take on the upcoming European CRCF and how that could play with the essentially your businesses.
You named so many things, but I didn't hear anything else aside from, I think, the second one. So a lot of questions about the standards. There are many standards, and there are more upcoming. It just keeps on coming. And there are new requirements, and it changes all the time. When we work with producers to develop carbon projects and commercialize the credits, we have to think about choosing the standard that makes most sense for them. They carry, again, I think we're pretty analytics people, but in a practical way, they each carry pros and cons. I can make some quick example of this, not to put anyone on the spot. It just, there are some models that fit better for certain projects than others. There are some location aspects. So there are standards that may be more focused in Europe versus the rest of the world. There's also, it's not ready, but the Climate Action Reserve, if it's ever going to be ready, methodology that will just focus on North America. So that's the first thing. But I think the two most sensitive things are timelines and costs, generally for project developers. Example with Puro. Puro takes a percentage, right, of the sale of a credit. But it doesn't really cost much to get registered and go through the thing because the audit is covered within that percentage. So really the cost of the certification, aside from the development, which is up to the developer to figure out, is on a percentage when the credits are sold. But on a different side, for example, CSI or Vera, they've taken, let's say, a more classic route where the charge for certification is a specific set dollar amount. So in some cases, the percentage can be much higher at the end of the day, but you don't necessarily have that barrier upfront cost. There are some people who are well-funded, right, that have development capital, who may be more willing to put up more upfront and to lower that cost over time. So that's one example. And the second one is timeline. Auditor backlog is massive and is most important at Vera, for example. So if you want to certify a project at Vera, probably need a full year if it's not 18 months. That is different, let's say, than CSI, who can do it, from my understanding, much quicker. Maybe you have more experience there. Like, what, 5 months, 4 months?
3 to 6 months. 3 to 6 months.
And then with Puro, again, depending on the audits and the backlog, would say it's a little bit longer. Than 3 months is a little short on notice on the auditors. So let's say, would 5 to 8 make sense? Yeah.
Depend on the starting point of the accounting, but you need some months of operations to collect the data, and from that have the auditors 3 months. So yeah, 3 plus 3 would be a good average, 6 months.
So you've got these differences, but these are just 2 or 3 examples. So
to be fair, I also perceive cases where for CSI took longer than 6 months. So I would say Pro and CSI, there's not much difference in terms of timeline, how long it takes to get certified. And there are different obstacles, and if you reach such an obstacle, it just takes significantly longer, or can take significantly longer. But everything is quicker than Vera.
these were my thoughts on the standards.
Yeah. Do you want to react, Marcel?
Yeah, I mean, like with regards to the standards, we are also very pragmatic, meaning that we want to integrate with standards that have, a biochar methodology that we deem like good enough, and then just try to use synergies, align, and be in general, in principle, standard agnostic, as long as the standard meets our minimum criteria that we set for ourselves. And I think you need to repeat the other questions again.
I will.
On the standard also, as a standard, I can have, of course, biased opinion, but I think relatively objectively, you need several standards to keep them on their toes. I mean, look at us. We are at the third version of, biochar. So it means that it drives standards to be the best they can to maintain a certain level of quality. Now, of course, it has a disadvantage for the buyers, to be a little bit confusing. And that's where today, you really much need the experts sitting around me to help navigate through these complex markets. So I think it's doable. It has a cost, a transaction cost, which is a bit of a bummer for many, buyers. But as the project starts to scale, relatively speaking, those fixed fee become relatively smaller and are no barrier anymore. So we're still into this transitioning into a more mature market, and as it will, transaction costs will not be a problem, and I believe several standards can be maintained.
I think that's also what's driving the permanence discussion to a great extent. And I mean, the more science we have on this discussion, the more like trust we can also bring to the buyer again. So I think it's very important, like that all the standards are driving this discussion.
Thanks. So I guess the other parts of my question were first, what is your take on the evolution of the motivations for the buyers to acquire biochar or more broadly CDR credits? And then specifically, do you have a take or expectations when the CRCF, so the Carbon Removal Certification Framework, comes online in Europe, and what that may change for you?
Okay, I can go first. Perhaps on the motivation, I'll not use my own brain resources, but lazily just pick them up from CDR FYI. The report from a survey they conducted with many buyers on the motivation, so you can have a split down about what's motivating them in 2023 and what's seemingly motivating them going forward. So surprisingly so, the majority of those buyers, which is again a microcosm of a very concentrated pool of proactive pioneer buyers, they are going through the exercise more to learn and establish network and relationship with project developers. It only comes to third that they would actually buy to neutralize of their own emission, like buying forward for offtakes, etc. So this motivation are gonna, in the future, of course, be less and less as regulators, or perhaps when SBTi decides to set two different targets for reduction and for carbon removal, then buyers will have to procure for negative emissions, and that will become the main motivation, and we hope that will come very soon.
I mean, it's one motivation that why buyers come to us is, I guess, the additional trust layer, so the DMRV, of course. But on the other hand, I think geography also plays an important role. So, I mean, we started off in Germany. We have a lot of projects in German-speaking countries, and as my colleagues already mentioned, it's often like a very target-specific market where buyers come and say, I want a project from this geography, basically. So I would say price and geography and this please in my backyard attitude, they play a big role actually for buyers.
Yeah, fully agree on that one there. But perhaps there is somewhat evolution which has happened during the last couple of years. Some of the earlier players were very much putting money out there just to try this out, see what it's like, try to create a market, and that's great. Fantastic thing to do if you're in that position. From our point of view, then I think there is more of a switch towards companies trying to or making claims on these credits. The registries are publicly available, so anyone can go in and see who's bought credits and retired them and the beneficiaries. And they can see which project they've chosen, and one can also kind of have an opinion as to why they're doing that. To our knowledge, then almost every credit that's been issued has been retired for a purpose, and that purpose is almost always abatement or usage against emissions. So these are being used as compensation for value chain emissions. They are typically also being used by companies that have already done a lot to manage their own emissions, their own direct emissions. So I would say that these are usually very buyers who have thought this through, worked with this for a number of years, and have very good control over their own emissions, and they're doing this as the final piece of their current emissions management strategy.
Thanks. Do you want to jump in?
So there are two things in terms of the standards. For sure, there is a requirement of the standardization of the standards. I'm not sure how it will happen, but yeah, we really look forward to have fewer standards. In terms of the buyers, to be very honest, I guess when we started, we had this thing that, I mean, I'm sure it's like everyone is aware that there is some knowledge gap exists in terms of the buyers, but which is, I guess, is exponentially closing up, because when we started, there were very few buyers of the artisanal biochar, and suddenly we see there's a lot of interest growing among buyers for the artisanal biochar. A couple of people from the industry has you can say already signed a huge offtake agreement. We are also in discussion with a few, but yeah, I see. But there's this knowledge gap which exists, which really need to be filled up as soon as possible for the greater good, I guess. So yeah.
I want to add a motivation really quickly. We've seen, especially in the last 6 months approaching the COP that happened in December, we've seen from speaking with buyers that there is a huge consideration for Article 6. Buyers are asking about, within a specific geography, do you know, or are there plans to, adopt Article 6? And so when it comes out, there were some mentions earlier about government and legislation, and I think that's a big motivator that's coming, that's pushing, especially large companies, to really think about, okay, in 5 to 10 years, I'm going to have to comply with my government, who has to comply with this. And that's, I think, a really big motivator that's coming in. And it touches a little bit on the EU CDR framework, right? We're also seeing some of that.
Yeah, for us that's very important, since we have a strong presence in Europe, and we also have a very strong buyer pipeline in Europe. And I mean, we hired an entire person like that is just following this whole policy debates, Article 6, CSCF, also sitting in several boards, trying to influence the discussion and the outcome, and with the DMRV trying to get ready for requirements that will be set out in the compliance market. So from our point of view, this will have a huge impact also on our business. And yeah.
Thank you. Let's go to the room with questions. I see one there.
Hey, Morten Haik from Stigsdal Skyclean in Denmark. So now we are at the biogas conference. I think we are lacking a bit of connection between biochar certificates and biogas, because what we are looking at in some of our projects is to combine the biochar certificates with the biogas certificates. And basically what we see is if you build a project with a pyrolysis plant together with a biogas plant, you can actually use the biochar certificates for the biogas certificate. So you don't issue them as a carbon removal certificate, you simply deduct it in the biogas CI score, which enables the CI score to be well above 100, at least for the projects we are looking at. And that indirectly gives a biochar certificate price of around 500 euros per ton. So this is also part of the projects we're working at now, and we just today announced a new project that we're looking at with together with a biogas plant. And the reason we are able to finance this project is basically because we use the biochar certificates together with biogas. Do you see any like a way of in the future for this being the way forward to get projects done? Is like combining them with energy parks and bigger projects?
Feel like I talk a lot. But yeah, it's a really good strategy. We've seen a lot of people ask similar questions around stacking of credits, especially in North America with, for example, LCFS programs in California. We've actually spoken to LCFS recently, and you can do that. It's just that basically you deduct the, well, it's an energy allocation quantification piece, right? So you're removing all of the process emissions from the biogas and put it into the biochar, and then I guess you guys are using it a little bit in this way. I don't know the specifics, but this is something that we really believe in. We have to optimize using these different, existing crediting system, whether it's tax credits and or bioenergy credits and or the carbon removal credits. What we want to make sure is that we are not double counting anything. So that's really, really important. And the other piece is around the different credit types. There are biogas credits, which are renewable energy credits, which can be under the reduction, right, credits. And then there's removal credits. And so should the reduction credit be more valuable than a removal credit? I'm not going to answer that question. I don't know the answer, but I think this type of structure, if that is successful, it will highly influence the way that projects are getting built, where those structures are. So I think it's a great strategy.
Anyone else to react?
I mean, I can only say I agree. Like, what needs to be avoided is double counting, and there needs to be proper accounting. But as long as you have these schemes available, and you're not, I would say, creating windfall profits, but reinvest, drive scaling, I don't see any reason why you shouldn't tap into this. I mean, that's what it's there for, basically, from our point of view. And it makes a lot of sense to combine these different pools and tap into them, again, as long as there's proper monitoring and accounting in place.
Of course, this strategy has the benefit that you are allocating yourself, so then it's very much market driven, and see if the maths adds up as the market evolve. As of now, it may be a little bit of a stretch, but if you find long-term sponsor, having a bit of a higher price in the beginning of the projects is aligning interest in de-risking, and then as the market matures, hopefully you get the cost curve that the buyers of those credit expects. But it's very encouraging to see more and more projects looking into those opportunities.
And
Thank you.
I talked to a couple of buyers that expect exactly this. You start with a higher price and then cost curve goes down over time. So it's, I would say, pretty attractive to a potential buyer of credits. Even.
Excellent. We still have time for one or two questions. Yeah.
Yeah, I would like to bring up the question of pre-corks or pre-certificates, pre-selling. Of course, we've seen a tremendous surge in interest around biochar these last 2 years as the voluntary carbon market has evolved and stabilized thanks to Puro and Carbon Futures, CSI. What is the risk, however, when these pre-corks don't materialize? And is this something that the industry is working to safeguard? Because, of course, the risk is that the whole market could implode if too many pre-corks are sold. Let's say the market has created a lot of interest and it's developing and it's great, but maybe sometimes the expectations, like many of you have said, are higher than what's actually possible. And if this is being financed through pre-corks that never see the light of day, how do you see that? What's the real risk in the market? And of course, we all want to prevent that this causes unnecessary scandals in this industry.
Thank you. I feel this question is addressed to me. So that's a great opportunity for me to clarify some things that was probably missing in my presentation. So thank you for bringing that up. Old news. Pre-corks as digital assets to channel prepayments are discontinued. We're not channeling prepayment via digital assets. We had, put a lot of efforts trying to build a framework with de-risking via assessments, via tracking and different priorities for buyers that prepay versus the buyers that get the credits at delivery, etc. We really, out of good intentions, tried to build a framework that would fit relatively for all, and it was not working because what the market needs is the flexibility. And we realized along the way that what the value add was actually more on the tracking of the future corks, whether they're prepaid or paid at delivery. Who are we to decide? This is a commercial negotiation between the projects and the buyer, and the different hedging strategy and price optimization. So what we've focused now has been, our focus has shifted from trying to force one fit-for-all framework into a more flexible, enabling transactions between buyers and suppliers to be led commercially between themselves, but doubling down on the tracking and offering more of a lean certification journey where there can be milestones that can help buyer get a bit more comfortable before they commit. So that was an excellent question. I hope I answered it okay.
Was great.
Thanks. Next question.
Hey, Tristan from Carbon Pilots. So today, most biochar carbon credits are sold as offsets, but the great part about biochar is it can be used as an insetting project to decarbonize existing industries. So think of a cement manufacturer using biochar or pigment or farming. Do you see an increase in these number of projects where the carbon credit is combined with the actual project developer? And what does it look like in a space where insetting, there are more insetting projects, and how does project finance different in this scenario, and how does the existing carbon registries deal with the insetting projects?
We already do this actually via our platform. Also shout out to Ecolocked who started a project mainly based on insetting with us, and it's already done in this case together with Carbon Standards International. So the functionalities are already there. I would say what drives this is not that it's not possible or that the functionalities are not there. It's really a lot of times you need the revenue from the carbon credit in order to make your business profitable, or at least cover your production cost. So it's really more of a question, how much can you get for your biochar in order to be able to do insetting and actually claim the carbon offset for yourself and for your product. So
yeah, maybe just to shoot in there. Absolutely possible. There are a couple of companies that we're aware of who are doing that. They are selling biochar with carbon credits to a company who wants both for various reasons. It's perfectly possible to use the credits, cancel them in the registry, create the whole audit trail. So that's absolutely possible, and a very interesting development for various different materials going forward. It takes away the risk of having to sell the biochar as well. So you're kind of accumulating and reducing a risk. So yeah, absolutely.
Maybe the additional element that is involved that took a little bit time to develop, for example, in the construction sectors, is the Environmental Product Declaration, EPD, that is being used here in Europe. So, but yeah, we are also getting there, and the first EPDs for biochar-based construction materials are currently coming out.
Just as a note, we would expect, not in every cases, but we would expect probably lower prices, just because, you know, the same company is buying everything. Oftentimes they don't necessarily associate the same, you know, relative value to both products rather than being sold separately.
Excellent. Do we have one last question maybe? Yeah, over there.
Thank you for these nice presentations, very interesting. We have been talking about certificates and risk, but my question is regarding the ability to put the biochar in the market. Do you think there are how do you think the regulation environment will evolve in the coming years, or do you think there is a lot of work to do regarding how we will be able to put the biochar in the market? Sometimes we have the idea of the possibility with different customers to produce biochar, but we don't know how exactly we are going to use biochar at the end. So I don't know if it's a barrier right now.
Where are you located?
In France.
I would always look at this from a product perspective and not think, okay, how can I sell my biochar? Because selling biochar as a product as it is very difficult, at least from what I know. But if you turn it into a product like organic fertilizer, you know, replacement for natural fertilizer, or you go into the retail market and really have a soy substrate that is labeled with a specific usage, also feed additive to a certain extent, different mixtures for construction material and material applications, you know, then usually it's still difficult, don't get me wrong, but it's easier, and like you basically have a clear product with a clear market you want to tap into, where you can do clear marketing, whereas if you just want to sell biochar, you have many opportunities, but all of them are rather difficult to tap into right now. So first think about what is the product that you want to make with the biochar.
Also remembering that, you know, 5 years ago, before a standard would certify the negative emission allocated to biochar, you know, you would not get additional revenues that are needed to make those projects viable or like more scalable. So it's a bit a native, of course, industry where historically, biochar has not been produced in consistent quality and regular, highly predictable big volumes to be commoditized, so to say, where you could get large buyers taking long-term offtake agreements to supply because they're convinced of it. So we're now seeing a lot of traction. This conference is getting bigger and bigger every year. I think that's the benefit of the carbon credits, to add the cash flow streams that was missing for this to happen. So we're still in the beginning of this, and believing that so many projects will start, you know, being in operations, and buyers will realize that it's more predictable to anticipate the quality of the biochar, that those are going to be more and more productized. It will help tremendously, you know, with the buyer relationships.
I can give you a bit more perspective regarding the demand being generated. So, like a year back, at least in Southeast Asia, because we have mainly in artisanal biochar, or Africa, so people were like, they don't know what biochar is, so they can't put it in their soil, right? But as soon as there is some literature or some pilot project or studies by this research institute which is being done, now they are very open to use it. So this is, you can say, is for general you can say farmers, there's this another segment of farmers who are organic producers, right? So they are the one, they can't use chemical fertilizers or other things. So the only way they can improve their yield and fertility is by mixing biochar with their existing organic fertilizers, right? So there is this one more side to it, which is Africa. So in Africa, the price for the chemical fertilizers is very much high, right? So the easiest and simplest solution they have is that, okay, if they are producing biochar, they mix it with some compost, or you can say cow dung or something like this, and they use it in the soil. I'm not sure about Europe, but like for the developing world, this is the case. And 6 months before, there was no demand, and now at least you have this $250 to $300 per ton of biochar demand coming at least from India, which I know, and same for, you can say, other regions. So yeah, I guess this gap is there, because if I'm a farmer, I don't know how it is going to benefit my crops, in which way, how much should I apply, in which type of soil. So there's this gap which is there in terms of literature. So that's what needed to be filled. At least we are doing that for India by partnering with a lot of universities and research.
Yeah, thank you. Because also the specific regulation in each country should encourage the use of biochar or not, so it depends.
In the EU, thanks for answering the question about location. In the EU, there are different regulations that are going to come into play that are not necessarily, or that are in place, but that are not necessarily super mature yet, that will really help. Amongst other things, what we mentioned earlier, the framework, I keep calling it the EU CDR framework. What is it called?
CRCF, so that's Carbon Removal Certification Framework.
So if it's not really mature, we don't know. If this enters as part of the EU ETS, which is a compliance market, then all of the large industrials that are subjected to this compliance market will have another incentive to adopt or buy biochar and use it. If it's quantified within, their emissions. So it depends a lot. But the second piece is a bit more imminent, is the CBAM, the Carbon Border Adjustment Mechanism in Europe, where certain commodities like fertilizers, cement, but also steel and aluminum, for example, are being, well, I'm not going to go through the quantification, but the imports are being taxed on carbon intensity based on European carbon EU ETS pricing, basically. That's really basic understanding. And so when it is applied to fertilizers, concrete manufacturers, less maybe important in steel because we're on a panel for carbon and there's no CDRs for usage in steel, well, those should also help increase visibility for these large industrial that are already working on it, but push them further. So there is good directions in terms of the legislation, and probably we can do a shout out to the European Biochar Industry Group Association that are working really hard on policy and lobbying on this.
And then again, it also makes a lot of sense, I guess, to reach out to organizations in between, like Biochar Zero, NCHAR, Ecoloct, Castor-Con in the construction materials sector. So.
Okay, thank you very much. It is now time to wrap up this session. So I would like to warmly thank all our panelists for all the insight they've shared. Let's give them a round of applause, please. And thanks also to all of you for following this session up until the end.
Can we give a big shout out to many of the people that stayed for 2 hours 20 on their chairs?
Yeah, that's true.
I would have never done that in university if you tell me 2 hours.
Let's give
20.
a round of applause to our
Please,
audience.
big round of applause to you guys.
Thank you very much.
Oui, bah oui. Non, non, mais comme je fais les retours du côté que je ne sais pas ce qui se passe sur le plateau, je vérifie des fois que... Voilà.
You have this for your presentation.
That's the point. Okay, good.
Yeah, to pass the slides.
Ich wollte gar nicht alleine hin. Das ist nett.
Is it yours or the previous person?
This one.
Oh, okay, perfect.
Eduardo from ETIA. Okay, Marcel, company card.
Nice to meet you. So, doesn't matter the way that we place here.
All right. If Jan Lindenberger and Pierre CREPIN could come to the stage, please, we could start. Here they are. While they take their seats, I'll introduce myself real quick. Welcome and thank you for showing up today. My name is Leopold STEINBEIS. I am the Managing Director for the German Biochar Association, and it is my honor to moderate this next panel. We will, without further ado, because we're 20 minutes late, start with our first presentation done by Marcel RENSMANN of the Pyreg company. He is a trained environmental protection engineer and has over 11 years experience in the field and has been working for Pyreg. He's currently working as the head of technical sales. His presentation today is going to be about the topic everything but wood, multi-material capable technology, and I have a suspicion that this has to do with Pyreg's multi-capable technology. Thank you, Marcel, and the stage is yours.
Thank you very much for the kind words. That is correct. So we have a multi-material capable technology, and I will present a little bit of the technology basics today, and then I will go and elaborate a little bit further on why not we should only focus on wood all the time. A brief history of the company. The company was initially made in the early 90s with a research project. It was not yet a company, it was a research project about wood gasification, making electricity affordable at remote areas. And that was good for wood, and there's the cycle beginning, but it was a problem when the wood price was increasing and it was not technically feasible to make economically challenging wood price and electricity prices. Hence, we were focusing on other biomasses which were a little bit more decentral, not transport worthy, maybe a little bit wet, and maybe a little bit heterogeneous, and nothing that typically goes into gasifiers as well. That was successful. We were making our first pilot plants. We were founding out the company in 2009, and now we are 15 years later, one of the leading companies, I would say, in the field of biomass carbonization, making biochars. And over the last years, we have also established a subsidiary in the US, which is a very dynamic market, which was boosted basically a lot by the subject of getting carbon removal credits into place when applying biochar to eligible applications. For that reason, we are also, I believe, the first ever technology partner to the Puro methodology, and we are also EBC pre-certified when it comes to the biochar certification itself. As a company, we have approximately 100 employees, and we are looking at approximately 65 sales of Pyreg equipments on a global scale. When it comes to the technology, I will quickly explain that to you. So what you see here is our modular skid for the PX 1500 unit. And the process, real quick explained, is that we burn conventional gas in our burning chamber, where we create hot exhaust gases. These are heating up our reactor, where the carbonization later will take place. And this area inside is totally separated from the outside area. So it's basically a tube-in-tube system that is forming this annular space where the hot exhaust gases are heating up the inner reactor area. As soon as we have some 400 degrees C in that reactor area, we start introducing the biomass, which must pass a rotary wheel sluice to not allow oxygen entering the process. We do tolerate a certain amount of oxygen here, but it's not a clean, typical, conventionally applied pyrolysis. We call it carbonization for a reason, because the purpose is to make biochar. When the biomass is dropping into this hot environment, we see an increase of processing temperatures at the process gas to approximately 600 to 700 degrees C. And by that temperature, we're creating biochar and burnable process or syngas. And we take out the process or syngas and introduce it to the combustion chamber to replace the conventional gas supply. So from that moment on, the system is fully self-sustainable and just operates on the energy that is brought in by the biomass in the first place. We have a process gas filter system here to take out all the dusty particles to avoid any clogging and contact surfaces being inefficient here where the hot exhaust is about to be heating the biomass. When the exhaust is leaving at approximately 800 to 900 degrees here, we start using that directly in exhaust gas heat exchangers, which can be deployed in a fashion the customer needs for his purpose. So it could be a hot water heat exchanger, it could be a steam heat exchanger for providing process energy, or it could be a fully integrated organic Rankine cycle system to co-generate electricity and recover some excess warm water for heating or drying purposes. Then we have our fans, which are making sure that the gases are moving in the direction we need it for the process. So we start here with a very slight vacuum, and then we take the gas to the combustion chamber, throughout the outer casing, and through the other devices. And here, then we have a higher vacuum under pressure. It will depend on the biomass whether we need to deploy optionally available exhaust scrubbing systems against acidic components like sulfur dioxide, as well as activated carbon filtration for any sort of heavy metal that might be within the biomass, which is not typically happening for conventional biomasses, but figure sludges, wastewater sludges, biosolids, etc. There you will have cadmium and mercury. At the end, we go to the chimney and release clean exhaust. The system here is approximately capable of 1.5 megawatt of input fuel power, which corresponds to approximately 3,500 tons of biomass and to approximately 900 tons of biochar. Here, the next system is approximately 4 times that capacity and is our newest development. You will learn you will learn about more of that tomorrow with the presentation of our CTO Helmut Gerber. We call that the PX 6000. Also, hopefully quickly enough, Pyreg's USPs. I will not read all of that to you as an audience. You will also have later access to that presentation. What we take some pride in our machine is that we have very long lifetimes of more than 15 years. We use quality fabrics, we use quality steels, sometimes even not steels anymore, to make sure that even with complicated biomasses, and we come to that point in a couple of minutes, will not be rotting away. There will be no corrosion and no problems using metal-based fabrics. Furthermore, the system is fully automated, fully controlled from remote, and you have plenty and tons of sensors and actuators to make sure that the system is running as smooth and as independent as possible from operators. We only need a half a person per day for operating our systems. When we deploy systems, we typically look at 4 potential revenue streams for our customers. The first one is associated with the biomass. Provided you don't have to buy wood, you may have something that is a leftover from a processing step, or it's maybe a residual stuff, or it's actually sort of waste that needs to be disposed of. Sometimes there's costs associated to that. If that's the case, this is the first potential revenue stream for an operator. The next revenue stream is with the carbonization itself, the production of excess thermal energy. I just described that you can use that for different purposes. So this is the next potential revenue stream, aside of the majority of what comes in on a revenue basis, which is the biochar. You can apply biochar to soil applications, or for instance to construction materials, to make sure that these become carbon negative or carbon neutral. And if that is the case, that you put the biochar into some sort of fixed and stable metrics, you will be eligible to generate carbon removal credits, which can be sold on the voluntary market for companies that are looking to polish their balance or to equate emissions that are hard to abate. multi-material capable. Now we come to the main dish. We see here pictures of different potential biomass streams indicating what our technology is capable of doing. Obviously, there is wood. Obviously, there is wood processing residues, but there's also, for instance, packaging material, anything that is related to livestock farming or agricultural practices, as well as lots of food processing residues, no matter whether it is coffee roasting, it's chocolate production, or it might be some sort of nut pelling, nut shields, etc., etc. Olive obviously is a great core. Olive core is obviously a great material as well. When you look at biochar systems, you often have a certain amount of biomass that is going in and a certain amount of biochar that is coming out. And there is a lot of dependencies that many people, especially when talking first about biochar, or if you're interested in getting a biochar machine, you're not aware of the dependencies that the biochar production is compared to the biomass you're deploying. And I brought a couple of graphs, and I promise I will not be hanging too much on them. You see that the mass conversion and the biochar carbon content can depend a lot on the biomass ash content. And for the lower graph, I also brought the R squared. I'm missing the English term for the exact parameter, sorry for that, correlation. And you see that with the increasing biomass ash content, you will see an increasing mass conversion. And with a decreasing ash content, you see you will have decreasing biochar carbon content. So when people ask me, why don't you have a high carbon content with sewage sludge, then it's obviously because everything that is we label here organic can be sewage sludge is having a very high ash content. And when you go into lignitic cellulosic biomass sources here, color-coded, you see that they have a low ash content, and that's why the resulting product obviously is carbon. That's the purpose of a carbonization machine. And there's more to that. When you look into how it correlates, it is not only the ash and not only the carbon, it is also depending on what is your carbon structure in your biomass. And that's why we separated a little bit cellulosic, lignitic, organic, and waste materials. You can see clearly, well, the R squared is not ideal anymore, but you can clearly see that with woody or cellulosic materials over here, you have a high carbon fixed content, and with the high carbon fixed content, you also yield stable and more carbon than it would be with an organic fraction, where you have more like fatty acids, proteins, and sugar in the biomass. So this is a very important assessment, what to do with your biochar, and we come later to that to assess what are you looking for when producing biochar. Are you getting rid of some waste, or is it that you are looking for to specific applications of the biochar? And when you, for instance, need pores for your whatever you're doing with the biochar, then you would not look into organic-based materials, because they don't basically come up with biochar with pores. Depending, as I said, depending on the biomass in the first place, you see that there's different biomass properties like ash content, carbon content, etc. And your conversion rate relates to that, as well as the carbon content in the biochar relates to that a lot. And this is, again, you will have the presentation, so you don't need to elaborate here more. It is important to understand that the biomass is influencing your biochar by a lot, not only the technology, it's also in the biomass. That's very important to know. Another example. Why is sludge not having biochar, and why a lot of carbon content in the biochar, and why is wood having, on the other hand, a lot of carbon in the biochar? And you see that when you have a biomass composition, which is 100% here, and you share, or you display the shares of ash, organics, which is not carbon, and within the carbon, the share of C6. You see that when during the process, you treat such biomasses with thermal energy or with heat, you will get the C6 out, very little amounts of the other organics, as well as the non-stable carbon and the ash. You don't really treat the ash. Ash is inert. There's nothing happening to it. It just stays with the biochar. And the same is with wood. But with a very low ash content and a much larger share of these volatile organics, I would say, you see that that is the reason why mass conversion and carbon contents are so different from biomass to biomass. why are we talking about other sources than wood? Because in Germany we see a strong movement that wood is getting more and more expensive. It follows the oil price, which is obvious as a fuel. But also, in the future, we don't want to burn gas anymore because we don't want to import gas from Russia. And we don't want to burn gas because it's releasing CO2. That's why, especially in district heating, etc., we see a lot of initiatives to go into wood combustion facilities. And the problem with wood combustion facilities is that the EU doesn't really want biomasses to be burned because it releases CO2. That's why we anticipate that with the emerging capabilities of carbon capture and storage solutions, we will see a pressure on biomass sources. And when you look at biomass prices, especially for quality wood materials, which is wood chips over here, or leftovers from the wood chip production, you always see increasing prices. Not to tell about pellets, which rose like crazy in the last years. And this volatility in prices and the unpredictability of these prices and developments in the future are a risk to any business case in biochar production. That being said, why not looking to other biomasses? I said that 20 times already, so excuse me for that. But why not looking into agricultural residues? They are burned on the fields anyway. Where's the point in not using such material at the places where they're generated? You can produce quality biochar from that. And we see that in some areas, even this procedure is not allowed anymore. And in California, which is a major agricultural region, it is effectively banned, and the people don't know what to do with that. Imagine you are a peanut farmer and you don't know what to do with the residues. They presently burn it. In the future, nobody knows. Probably costs will be associated to it. That's why there was an interesting research a couple of days ago published where the biochar potential from agricultural crop residues was estimated. And this is a graph from that study. I linked the source here so you can follow on that. You see that there's on a global scale, and you take out the desert areas, basically everywhere is biomass grown. In some areas more productive, in some areas not. But you clearly see biomass is everywhere, and there are particular regions where biomass is growing much better than in others, but biomass is everywhere available, especially crop residues. That being said, we see that the crop residues that are burned on the field is to a great extent of carbon in the total scale. And when you see what is burned, it is cereal, it is oil and oil fruits and other agricultural products. And when you take out some examples of these lists over here, you see that with that type of waste materials, and I was free enough to add some sort of other products over here. Chicken manure is something we get questioned like daily now. You have digestates, you have biosolids. You see that all of these different products have different carbon dioxide removal potentials and different biochar contents and different mass conversions. And with a large mass conversion and a low carbon content, you sort of compensate a little bit that your carbon content is lower because you produce more material with a lower carbon content. And ultimately, all of these sources are contributing to net zero goals when locking away carbon. Final slide, and I promise I'm not trying to confuse everybody. This is this is an attempt to simplify it as much as possible without being reckless, to display what type of biochar property would be desirable in what application you want to put the biochar in. And just as an example, if you want to look at soil improving, we see in the research that a lot of that is associated to the surface area of the biochar. Well, there's more, obviously, but the surface area always has an effect. If you look into fertilization, the surface area is not really of importance, but the ash content is relevant because in the ash there's the phosphor, the potassium, and all of that that is important for the plants to take as for needs of growing. The carbon credit value, on the other hand, is not only depending on the H2C molar ratio, but this is a very, very strong incident or hint on how stable your biochar will be. Luckily, we will have a presentation, or maybe we had that presentation already, I'm not sure, about new methodologies to account for the stability, which is called random reflectance, which is giving great evidence or great research on how stable is biochar, aside of the known H2C molar ratio calculations we have seen in the past. And to take that hopefully not away from Mohamed Saneh, biochar is stable from what we know today. And that was my, hopefully not much more than 15 minutes, and I thank you very much for the attention.
Thank you very much, Marcel RENSMANN from Pyreg. Our next speaker, Jan Lindenberger, has over 10 years experience in food and agricultural industry and started working as sales engineer for Next Generation Elements. His presentation will be about the stepwise path into a CO2 negative economy. Jan Lindenberger, everyone.
Hello and good afternoon. Today I'm going to present you what we can offer to get stepwise into a CO2 negative economy. But first of all, let me give you a short introduction in our company history. We are a member of the Next Generation Group. The Next Generation Group is mainly focused on plastic waste recycling. The Next Generation Recycling Technologies, which was the first established company of the group, produces plants for mechanically recycling of post-consumer and post-industrial waste. But there is still a part of plastic waste which cannot be mechanically recycled. So, and this is the reason why the Next Generation Elements was found. Our main goal was to develop a process for the thermochemical recycling of plastic waste, and because of this, we developed our first reactor, the T-Cracker 1000. It's an electrical heated screw reactor. And out of this technique, we developed the T-Cracker direct heated. It's the reactor type which is used for biomass to biochar. So the reactor is integrated in the combustion chamber, which gives us a very compact design, and we fully burn all of the syngas directly afterwards the reactor in the combustion chamber. Now let me show you why are negative emissions so important. On this chart, the black line marks the net CO2 emissions in gigaton per year. And what we can see is that the gray area are the historical emissions, the brown one are the expected future emissions, and the green one are the expected future negative emissions. So, and if we want to reach net zero until 2050, we have to generate negative emissions at a large scale. So, and let's come to the point what we can offer to reach this goal. We offer two plant concepts, PyroPower and PyroDry. The core part of our concept is still the T-Cracker direct heated. On the concept PyroDry, we are focused on wet input materials like savage sludge, digestate, or chicken manure. On PyroPower, we focus on dry material like wood chips, or seeds, or straw. And the other difference between the concepts is the usage of the surplus heat. At PyroDry, we use the surplus heat directly in a rotation shaft dryer for the pre-drying of the input material. In PyroPower, we combine the T-Cracker with different systems to use the surplus heat, like organic Rankine cycle, or steam generation, or a tube gas boiler. Let us look more in detail on the PyroDry concept. The PyroDry concept combines the step of the thermal drying and carbonization in only one process. And so we can reach a mass reduction up to 88%. And our output is a decontaminated phosphorus and carbon enriched valid material. I give you a short overview of this, how the system works. The dewatered sludge, for example, comes into a moving floor container. From this moving floor container into the dryer, the rotary dryer. The rotary dryer is separated in 4 chambers. The material has to pass every chamber. So we got a continuous drying process. After the dryer, the material comes out with a dry matter of approx 90%. It's going to be pelletized, and this pelletized are pyrosated. The off-gas of the pyroization is directly used for the drying of the input material. So it's a complete, in itself, closed system. We offer 3 different sizes of this system: 5,000, 3,000, and 1,500. The figures stands for the input material which you convert per year. And you can see on this chart clearly that we have a really compact design with a length of only 11.5 and a width of only 11 meters. Now I show you some examples for multi-line systems, because in this step numbering up is a more secure solution than scaling up. We can combine we can combine for example 4 tea crackers with 6 dryers, because the tea cracker provides a little bit more energy than we need for the drying process. Now I'm going to present you our concept PyroPower. First step, I want to show you pictures of our operating reference plants. The first one in Offenhausen is near Nuremberg in Germany, and the second one in Austria. The company is called Sonnenerde. Here we have, for example, the PyroPower hot water system. On the back of the combustion chamber, a tube gas boiler is situated, and it's designed for a throughput up to 350 kilogram per hour and an output of a nominal power up to 800 kW thermal energy recovered as hot water with a temperature level of 90 degrees. And in generally, with the tea cracker direct heated, we reach a high quality of biochar with ultra low pH values. At the next slide, I show you our system PyroPower combined heat and power. It combines the tea cracker direct heated with the organic Rankine cycle, and you can see on the left side 2 moving floor containers, which allows us the pre-drying of the input material, so you can use as input material wood as it's delivered with 55% humidity, for example. The system is designed for an output from up to 90 kilogram per hour biochar and 120 kW electrical energy and 600 kW thermal energy, which is also recovered as hot water. On the right side, you see the organic mechanical cycle. We can scale them up and combine them with 40 crackers. Thank you for your attention. I hope I can give you a short overview of what we offer.
Thank you very much, Jan Lindenberger. Since both of you finished so early, I think we could take 2 minutes to have maybe 1 or 2 questions from the audience before we go on with our next 2 presentations. Are there any questions so far? I don't see any questions. All right, then we'll move on with our next presentation. Oh, we have one over here? Okay, thank you.
Hi, so I was just wondering, in terms of the technology, do you see any barriers in scaling up? I know Pyreg, you're looking on the PX6000 unit. Do you see any issues with scaling up to that, or are there any plans in the future to scale any further?
Scaling with the existing reactor design will be difficult because we are operating with this reactor design, and you have screws in there, and the reactor design is a tube-in-tube system, so you have a volume that is processed which needs to be heated by the surface, and you can just make it longer to increase the capacity because your screw will not be, it will turning like a banana, it will break eventually, so the screw has a limit in mechanical work. And from a thermodynamical point of view, if you increase the volume and the surface to it will not increase by the number of 3 like the volume does. So the specific ratio required from surface to heat a volume will not be matching out anymore. And that's why it's difficult to scale further as the reactor design we have today, which will likely cause much larger systems to be changing the concept of a screw reactor to something else. But yes, there's plans.
Thank you once again, Marcel. Any other questions so far? Okay, in that case, we will go on with our next candidate. Our next presentation will be held by Pierre-Emmanuel CREPIN. He is an architectural engineer with 30 years experience in the energy industry worldwide. He is currently the CEO of PyroCore, and his presentation will be about soil regeneration and new value chains. Pierre CREPIN, everyone.
Bonsoir à tous. Ah, parfait. Alors, je sais que les présentations préalables, notre stand est juste là, et les présentations préalables ont été faites toutes en anglais. Je pourrais le faire, mais je vais rester sur le français. Alors, j'ai intégré PyroCore il y a quelque temps déjà, et PyroCore est une société qui a été créée en 2018. C'est un concept qui reste classique sur le plan de la pyrolyse. C'est toujours le traitement des matériaux à haute température et en l'absence d'oxygène. Rien de nouveau dans la pyrolyse. C'est le concept, je crois qu'on le partage entre les différents acteurs de la pyrolyse. Alors, continuons là-dessus. Rapidement, je viens de vous expliquer, je vous expliquerai un peu plus tard l'historique de la société, nos différents stades. La plupart, en tout cas la principale, c'est qu'aujourd'hui nous sommes en pleine industrialisation de nos systèmes, de notre process. On a aujourd'hui différentes capacités, entre du 500 kWh, du 700 kWh, et on va jusqu'à aujourd'hui à travailler jusqu'à 1000 kWh. Alors, qui sommes-nous? Donc, effectivement, en 2018, création de la société PyroCore SA, qui a été effectivement subventionnée. On a 25 millions d'euros ont été investis dans le développement de cette technologie. Implémentation du premier contrat avec le ministère de la Défense britannique. Nous avons aujourd'hui 4 systèmes de pyrolyse installés sur les porte-avions de la Royal Navy. Nous avons aussi une installation qui nous sert un peu d'installation martyr sur laquelle on va faire tous les tests possibles et imaginables de façon à fiabiliser la technologie. En 2022, la phase d'expansion, je vais faire bref par rapport à l'ensemble. Et comme je vous le disais aujourd'hui, l'accélération industrielle avec un nombre significatif d'installations que nous avons prévues d'ici à la fin 2028. Alors ça va travailler à la fois, nous allons travailler effectivement sur la biomasse, c'est principalement notre rayon d'action, mais aussi à tous les matériaux dits CSR. Voici en gros notre installation. C'est l'installation que nous avons sur Avonmouth, puisque notre base de technologie est basée près de Bristol au Royaume-Uni. Nous avons notre siège social qui est situé à Bruxelles en Belgique et une autre entité à Paris en France. Donc effectivement, rapidement, c'est toujours le même principe. Sur la droite, vous voyez le kiln, en l'occurrence, qui est le réacteur à pyrolyse, qui est un système à double tube, donc avec une vis sans fin, l'ensemble faisant à peu près 9 mètres de long. Le thermal oxidizer qui permet en l'occurrence de brûler l'ensemble des gaz de synthèse que nous produisons suite à la pyrolyse, qui va entretenir l'action de pyrolyse de façon à ce que par la production d'énergie et la valorisation énergétique, que ce soit en électricité ou en chaleur, notre installation soit complètement autonome et puisse être utilisée en îlotage. Alors nous avons pris un parti assez particulier de façon notamment quant aux températures de traitement. En l'occurrence, vous voyez sur la courbe verte qui est la quantité de matière que l'on traite. En l'occurrence, plus la température de la pyrolyse est élevée, plus il est possible de traiter de grands flux de biomasse, mais la température trop élevée requiert davantage d'énergie et peut dégrader la qualité du biochar. On verra ça tout à l'heure. Le compromis à trouver réside dans l'action d'un rendement en char légèrement inférieur, mais plus stable et plus riche en carbone. C'est d'ailleurs sur le cercle vert que vous voyez les températures sur lesquelles nous allons travailler et pyrolyser la matière. En l'occurrence, le plus important, en tout cas pour nous, ce qui nous semble être le plus simple, le plus important, c'est arriver à ce que 1 tonne par heure d'apport en biomasse corresponde en gros à 800 kg de CO2 équivalent. Vous voyez donc en l'occurrence que plus on va monter en température, plus les chars vont diminuer. Et en l'occurrence, sur la courbe noire, c'est la quantité de carbone, en l'occurrence, qui va être séquestrée. Les avantages du biochar en agriculture. Alors effectivement, nous avons en agriculture la première utilisation que nous voyons aujourd'hui, et nous avons plusieurs projets à travers le monde c'est la régénération des sols. C'est en l'occurrence principalement cette régénération des sols pour effectivement améliorer les rendements agricoles. Alors ça peut être aussi, on parle agricole, mais ça peut aussi travailler sur la régénération des sols destinés à recevoir des forêts et accroître leur rendement. Nous avons la rétention des eaux et des nutriments. Nous avons différents produits que nous traitons, et notamment par rapport à des produits issus de l'industrie ou l'activité aquacole, en l'occurrence, qui nous permettent aussi d'apporter des biochars avec des hautes quantités de phosphate. Piégeage des contaminants et des lixivias, en particulier des nitrates. Il s'avère que les biochars intégrés dans les sols ont un rôle de filtre, en l'occurrence plus accru, qui permettent de réussir les nitrates et éviter que ces nitrates partent en nappe phréatique. Et la réduction aussi des gaz à effet de serre. En principe, les oxydes d'azote, les CH4, enfin, donc tout ce qui est méthane et le CO2. On va traiter, pour nous, effectivement, on va utiliser ces biochars dans le compostage. Ça va être lié, on va traiter les lisiers. On a aussi conduit des études qui permettent de dire que aujourd'hui, l'addition de biochar au niveau de la méthanisation permet d'augmenter jusqu'à 40% la production de méthane. Alors, vous avez ici j'allais dire, un panel de l'ensemble des utilisations possibles du biochar. Alors, on va pas les détailler tous ensemble, tous maintenant, mais principalement, sur ce que je disais préalablement, c'est l'amendement des sols, les supports et les engrais à libération lente, l'alimentation animale, les additifs, et les captures et stockages de carbone et le piégeage en sol. Alors, quelle matière et quels critères? Alors, chez PyroCore, nous nous basons principalement sur la certification ABC. Alors, c'est vrai que ces valeurs sont révisées, en tout cas les valeurs limites sont révisées tous les 6 mois. La certification de biochar en ABC Feed ou ABC Food permet l'intégration du biochar dans les chaînes alimentaires. Les certificats ABC Agro et Organique Agro répondent à toutes les exigences du nouveau règlement de l'Union européenne sur les produits fertilisants, respectivement sur l'agriculture biologique et classique. Le ABC Urban, UBC Consumer Materials et ABC Basic Materials. Mais en l'occurrence, vous voyez sur l'ensemble, la tête, la base sèche du char est analysée et comparée au standard ABC. Alors, notre activité de traitement de la biomasse, le procédé Phoenix convertit une vingtaine de types. En fait, sur l'ensemble des matériaux que PyroCore traite, et nous avons fait des essais positifs sur à peu près une quarantaine de matériaux, dont une vingtaine, 20-22 en biomasse uniquement. Donc aujourd'hui, effectivement, les copeaux de bois, je pense que tout le monde dans la pyrolyse se sert du wood chip et en tout cas des produits issus des filières bois. Mais le chanvre, aussi les coques de cacao, la litière des volailles qui pose des problèmes significatifs sur le plan environnemental. Les boues piscicoles, ça c'est aussi un axe sur lequel nous avançons énormément parce que les résultats liés au biochar que nous obtenons sont significatifs par rapport au pot de test que nous faisions, donc par rapport à l'augmentation de croissance des végétaux. Et les boues de steppe qui sont aussi un vecteur important pour nous. Sur l'ensemble de ces deux activités, on s'expose à peu près aujourd'hui à peu près 8 millions de tonnes de traitement par an. Alors, quelques exemples, parce qu'évidemment on ne fait pas prendre l'ensemble. Sur les copeaux de bois, le chanvre et les boues piscicoles. Par rapport au classement, donc sur les copeaux de bois, je pense que ces valeurs-là sont connues tout le monde. Vous avez en l'occurrence les valeurs limites qui sont imposées par Eurofins. C'est un laboratoire avec lequel nous travaillons en permanence, ce qui nous permet de faire évoluer la qualité de nos chars et nos recettes, en l'occurrence, et de calibration de nos machines pour obtenir les biochars. Vous voyez que sur ces valeurs, nous avons des valeurs, en l'occurrence, qui sont ici, qui sont conformes à la réglementation et parfois qui sont bien en dessous des valeurs qui sont limites. Effectivement, tout ce qui correspond, les hydrocarbures aromatiques, polycycliques, Vous voyez ici que nous avons des valeurs qui sont, alors je le vois ici, des valeurs qui sont à la limite du mesurable. Donc les rapports que en tout cas sur les benzènes, sur les benzofibro, j'arrive plus à le traduire en français, excusez-moi. Mais en tout cas, les valeurs qui sont obtenues sont bien en dessous des valeurs limites, et en tout cas des valeurs mesurables. Les tests sur les toxiques, effectivement, on a sur ces éléments-là, au niveau des PCD et des PCDF, vous voyez que les valeurs que nous obtenons par rapport au biochar que nous produisons, en tout cas sur les wood chips, pardon, j'ai fait une marche arrière. Je pense que c'est ça, voilà. En tout cas, les valeurs que nous obtenons sont bien inférieures aux valeurs limites, en tout cas pour le feed plus et les feed, en EBC feed plus et EBC feed. Les tests sur les biphényles polychlorés, effectivement, là nous avons aussi des valeurs qui sont très en dessous des valeurs, requises. En tout cas des valeurs limites acceptées, et notamment nous sommes, vous le voyez, par rapport à cet élément-là, nous sommes juste à la limite du détectable. Je vais aller un peu plus vite parce qu'on me fait signe qu'il faut effectivement que j'accélère. Donc vous voyez les données que nous obtenons. Alors effectivement, en fonction des différents tableaux et des différentes la forme des tableaux change, mais vous voyez qu'en l'occurrence les valeurs que nous obtenons sont très significatif. Juste un petit souci par rapport au chanvre, vous verrez que le pH, en l'occurrence que nous avons sur les chanvres, est très alcalin. Donc ne peut pas être utilisé dans tous les cas. La même chose quant aux hydrocarbures aromatiques polycycliques. Vous voyez, je continue. Alors les boues-piscicoles, ça c'est quelque chose qui est assez particulier parce que pour nous c'est un marché qui est assez significatif. Donc là effectivement on se retrouve avec des valeurs qui sont un peu plus hautes que celles par rapport à d'habitude. On est quand même dans les limites, dans la limite acceptable, mais néanmoins sur ces boues il y a des problématiques qui se posent principalement par rapport à des valeurs qui tiennent par rapport à la façon dont les poissons, en l'occurrence, sont alimentés. Et on va retrouver ces valeurs qui sont assez négatives, notamment par rapport au taux des métaux, notamment au niveau du cambium, au niveau des mercures et au niveau du zinc. Actuellement, nous travaillons de façon très poussée et nous sommes sur le point d'aboutir de façon à régler ces problématiques liées au traitement, enfin en tout cas à retirer ces métaux. Voilà. Alors, en gros, la synthèse des analyses sur des biochars issus de notre système de pyrolyse, c'est effectivement les principales, en tout cas la principale qualité, c'est effectivement le carbone organique. Les propriétés, par rapport, en tout cas pour les copeaux de bois, carbone organique. Les faiblesses, on n'en a pas vraiment trouvé, mais parce que c'est un produit qui est très courant et en l'occurrence qu'on mélange parfois même à d'autres produits de façon à obtenir des biochars qui soient beaucoup, en tout cas pour relever le coefficient calorifique des matériaux, de façon à pouvoir assurer l'autogénération, en tout cas le self-sustainability du process. La certification EBC, en l'occurrence, et EBC+, à laquelle nous conformons, et puis ensuite, effectivement, la valorisation biochar de qualité supérieure convenant à tous les types de valorisation. Alors, on a les mêmes résultats par rapport au chanvre, et surtout au niveau des boues piscicoles, il y a une principale qualité, c'est que les boues piscicoles apportent au niveau des sols une significative quantité de phosphate, de micronutriments. Alors on a toujours ce problème lié aux métaux, mais un traitement secondaire dont je vous parlais précédemment est en train de régler ce problème. Par contre, au niveau des boues piscicoles, effectivement, on reste sur les ABC Classic Materials et on les utilise principalement en additif au compost, parce que ce biochar ajouté au compost a un effet dont je vous parlais tout à l'heure, et donc fertilisant à haute teneur en phosphate. Donc, en l'occurrence, valoriser le biochar en tant que tel, oui ou non. En tout cas, le biochar, quant au chanvre, en l'occurrence, peut être utilisé comme tout autre biochar. Cependant, il y a des applications supplémentaires, comme dans des matériaux de construction. Et ça, nous travaillons avec des laboratoires à cet effet-là. Il y a un gros développement et des gros vecteurs de développement qui se font grâce au biochar par rapport aux matériaux de construction. D'autres applications vont émerger dans le temps, mais je pense qu'il y a des sujets sur lesquels, pour l'instant, nous restons un peu plus confidentiels. Le biochar issu des bouts de poisson et d'autres chars dérivés des boues, en l'occurrence, peuvent être utilisés dans des produits sous réserve de certains traitements supplémentaires. De toute façon, la pyrolyse en tant que telle est toujours un risque illoté. La préparation matière et l'utilisation et le traitement des matières en amont et en aval est souvent nécessaire. Alors les chars de type ABC Basic Material peuvent trouver une meilleure voie de valorisation qu'un biochar conventionnel, sous réserve d'éventuels traitements secondaires. Voilà. Alors en l'occurrence, je pense que je vais m'arrêter là. Alors, à part la conclusion, bien sûr, je pense que c'est un minimum. Alors, la valorisation des biochars nécessite une évaluation détaillée et une connaissance approfondie des besoins du marché diversifié et en croissance. La production de biochars doit avant tout être orientée vers la vente d'un produit final. Et ça, c'est un arbitrage qui est, en l'occurrence, parmi les options étant le plus souvent économique. Les biochars de PyroCore répondent aux critères ABC Feed et ABC Feed Plus. Ça, c'est l'avantage de notre système. En plus de ça, notre système est très modulaire, flexible, extensible. On parlait de scaling tout à l'heure, en fonction des différents modules que nous installons sur place. Nous avons des projets aujourd'hui jusqu'à 12 unités, notamment sur le traitement des boues, qui vont permettre des économies substantielles annuelles par rapport en l'occurrence ceux qui font face à ces boues. Le PyroCore peut ajuster les conditions du processus en fonction des spécifications de la matière première, parce que tout en dépend. En l'occurrence, parfois, effectivement, notre procédé est aujourd'hui mature, solide, mais effectivement, on a des flux matières qui sont basés sur des standards, mais effectivement, ces flux matières varient en fonction du feedstock, ou de la biomasse en l'occurrence, et sont toujours variables. PyroCore peut ajuster les conditions du processus, donc c'est ce que je disais tout à l'heure, et une démonstration peut être organisée. En tout cas, vous pouvez venir nous rejoindre sur Avonnement, on vous montrera la machine en état de fonctionnement. Une nouvelle configuration est en train d'arriver aujourd'hui que nous allons proposer très bientôt, qui sera installée dès le mois d'octobre en France. Et qui, elle, en l'occurrence, produira une énergie propre qui servira à la fois à sécher la biomasse, mais aussi à produire une énergie par rapport à une activité industrielle juste adjacente. Et aujourd'hui, la valorisation pyrolyse et surtout l'effet de décarbonation, en tout cas de carbone négatif des populations, me semble être pour moi un des meilleurs vecteurs de la pyrolyse. Merci à vous.
Merci beaucoup, Pierre CREPIN. Y a-t-il des questions? On attend pour une question ou deux. Aucune question? Bon alors, on va continuer. Voilà.
Il y a une question?
Bonjour, merci pour la présentation. J'ai une petite question. Est-ce qu'on peut mélanger du biochar issus de différents biomasses?
Oui, on le fait. C'est possible, bien sûr. Après, effectivement, quelle est la qualité de biochar que vous cherchez? Quel est le résultat final? Ça, c'est toujours possible. Mais je pense qu'aujourd'hui, quand on vient à envisager le mélange de deux matières différentes, c'est certainement la plupart du temps pour rehausser le niveau calorifique des matériaux de façon à assurer une indépendance, enfin une autogénération de la pyrolyse. C'est surtout pour ça. Sinon, on va essayer de rester le plus homogène possible dans la matière. Alors après, effectivement, il y a des matériaux. Alors là, on n'est plus du tout dans le contexte dit biochar, mais on va, par exemple, ajouter du wood chip au bout de step, ne serait-ce que pour remonter le coefficient calorifique, mais aussi pour augmenter la quantité de syngas qui sera produit. Oui, parce que au niveau des bouts de step, le coefficient calorifique est très bas.
Autre question? Bon, alors, on va continuer. We'll continue with our last presentation, this time by Eduardo ARIZA. He has an MBA in chemical engineering and over 12 years experience in oil and the gas sector. Nowadays, he is focusing on business development as a business development manager for ETIA and focuses on industry decarbonization. His presentation is going to be about exactly that topic, industry decarbonization by valorization of organic waste through pyrolysis.
So, bonjour tout le monde, and thank you very much for being here. I will try to do it very fast. It's almost running out of time. So, first of all, I will introduce BAO. BAO, we are a group that we are focused on decarbonize the industry. We have many patents for doing that. The idea is that we can provide you a solution for the decarbonized industry through our technologies. We have several technologies today. We have a strong backlog that we have been discussing with the strong industries today. We have a core competence within the sludge and the sludge handling. We have many of our colleagues are PhD that are working on it, and we have gotten quite interesting results about it. Today we are around 250 employees, many different nationalities, including mine. I'm from Colombia. So I'm here trying to explain you what we do and how we can help you to decarbonize the industry with the pyrolysis of biomass. That is our group. We are here, the ETIA, the French company that we are here. We are part of the BAO group. Scanship is the company that starts everything for create this group. They are in charge to manage the waste in the cruise industry. And we are here, ETIA, that we are expert more than 30 years in pyrolysis of biomass here in France. We have some technology that is called BioGreen. It's patent and developing here in France. And we have today the CH industry that our Norwegian colleagues, we are developing a huge reactor because the market is asking for. I think that I always have two slides that we love to talk about the difference between pyrolysis, gasification, and incineration. As you can see, there's a huge difference, and the products are different too. But we are talking about pyrolysis without any oxygen, and we always going to have like three products: char, biochar, or char, depending on oil and gas. Depending on the temperature that we are working, we are going to change the quality of the product. My colleagues have said that before. We increase the temperature, we're going to, we reduce the biochar yield, but we increase the carbon fix, and of course, we increase the heat value of that. Is depending on the application. For agriculture application, we stay here around 500 degrees. That will be more than enough for that kind of application today. We have 3 different technologies. The microwave assisted pyrolysis is a small one. This unit will be installed in the cruise industry. The first ship will have that technology. The idea is to treat that waste and produce biochar inside the ships. The BioGreen, the technology that we have developed here in France. We have several units running today. We can up to 1,000 kilograms per hour. And it was this technology that we have deployed our industrialization today. And as I said before, with our colleagues in Norway, we are developing the reactor up to 5 tons per hour. Why we are doing that? Because especially in the Nordics and United States, they are willing for biochar, they are willing for a bigger solution for producing more biochar. That is why our colleagues here, we are talking about scaling up. Because even though that the market is not mature enough, but we are ready for that moment. And the momentum is right now. That is why we are working very hard on it. So I will go directly to some examples that we have today in the industry. Why I say that the carbonizes through using pyrolysis, because we can have a waste, not only wood chips or the typical biomass, we can have a waste. Use it in our reactor, producing energy, that of course with the syngas, you're gonna use the energy, again, to produce some heat or some steam, or depending on the project, and of course biochar. This is one of the examples that we have today running, is with green waste. The other example is in Germany, is the company that are producing chocolate. We have some residue for that kind of production. The thing is that it's quite interesting because we are having that kind of waste, and we are using for producing some energy, some steam that they were using for the chocolate production, and of course they are valorizing the biochar today. You have to say that in Germany, the biochar would say the market is better than here, for example, in France, better than in Spain, and better than in Italy. But in Germany, we'll say that they have been talking more about biochar and application, and they are one step forward than us today. Another sample example that we have is in another customer in Switzerland. They have like a many waste, we say that, different kind of waste, bio waste, and the principle is the same. It's just for show you how simple we can have a good project and how hard is having a good project. Because you need to valorize, of course, the syngas. You need to valorize the syngas. You need to know what to do with the biochar, and it's always both questions that I ask all the people that I'm talking about the project. What are you going to do with the syngas? What are you going to do with the biochar? What is your business model? And then we work together in a business model, because it's important to understand what we can do, what will be the numbers at the end of the day, for knowing if we have a project or not. This one was the first cases that I show were more from biochar from the agriculture application. But today, this project is under construction in Norway. The name is Follum. That will be a bigger project today for producing biocarbon. We'll say biocarbon because it will be used as in the metallurgic industry. This is a different application. The condition for getting that biochar is different. Of course, the temperature will be around 700, 750 degrees. It's a market that's developing, and the industry, the heavy industry, they are asking for that kind of product today. This is the first line of 5 lines. The idea is to produce around 10,000 tons of biochar per year. Of course, we're going to use woody biomass, the kind of demolition wood, around 50,000 tons per year. And I would say that this is a massive step for us and for colleagues in Norway, because we are going to work together for the carbonized and heavy industry. I would say that it's one step. The industry needs many other technologies that are working together for the carbonized, but we are kind of proud to be part of that. And of course, as I said before, with the colleagues of C.H. Evensen in Norway, the market was, asking for more and more capacity. That is probably that we receive that kind of message for the customers. And now we are working very hard on scaling up the bigger reactor from our portfolio. That will be up to 5 tons per hour. The technology is different as the biogreen technology, but of course it depends on the project and the business case. And of course we're going to discuss, checking the best option. And this will be an alternative for a massive project, especially when they're going to need more than 10,000 tons the biochar per year. Not happy with that. Of course, we are talking about here biochar, but in parallel, we are working in different other topics because we know that our technology is kind of versatile and we can do many different things, like, for example, plastic pyrolysis. We have a couple of projects with that. One of them with Repsol in Spain, and the second one here in France. And of course, we have developed the application for end-of-life tires. That, of course, is not the subject today, but just this is good to know if you have any project in mind. That is one example that what we expect with our C.H. Evensen reactor. That will be the production and this more or less that we have in mind for the coming years. So thank you very much.
Thank you very much, Eduardo. This leaves us 13 minutes. We have to end at 6 sharp, so 13 minutes for questions to all the candidates. Any questions? Right here.
Well, if nobody's asking, some of you mentioned that you do process wastewater sludge, but I'm very curious to know the specifics of it, like in terms of the mineral content that it has and obviously the moisture. So how do you make an economically feasible project with that?
I guess this would be a question for either Marcel or Jan.
Hello. We have one operating plant in Nordhausen. It's in the north of Germany. It only operates with sewage sludge. In our system, in the PyroDry system, we put the input material is the dewatered sewage sludge with 20 to 25% dry matter. The project in Nordhausen is set up directly at the water treatment plant. So, because our concept is designed as a decentralized solution. And now in the middle of February, we are going to install bigger size, a PyroDry 5000 in the US in Illinois. It's a private person who operates the plant, and he also only operates with sewage sludge.
Thank you, Jan. Marcel, anything to add?
Yeah, I would like to add basically the same answer. So you need the material to be dried to a certain extent that conventionally you reach 10 megajoules per kilogram of input fuel. This is where the material brings in enough energy to have a self-sustaining process. It is a little bit different from the technology that the colleagues are using there, but overall you can't tolerate too much water because the biomass will not have enough energy to create enough for circling. And so this is what combines all the different technologies. When it comes to the quality of the sewage sludge, we have seen organic contents from 20 to 80%. And conventional municipal sewage sludges typically are around an ash content of, don't shoot me, 40 to 60. 60 when they use lime for stabilizing, which is going out of business. And with any sludge, speaking for our technology, any sludge that is having around 50% of organics, you typically get to the 10 megajoules threshold when drying the sludge with sort of belt drying. And we have excess energy to provide approximately 50%, maybe 60% of the road for drying that. And that is a prerequisite. You need to have it dried, and you need to have a certain minimum amount of energy in it. Among our 5 or 6 installations, the financials work out because the disposal and transportation of the sludge in the first place is paying off for the entire equipment, including the drying, including the surroundings of everything. And that is only increasing over time. It was starting in Germany for us, where the prices were very high, and now in the US, they just rocket. I don't exactly understand the reason, but they're rocketing like crazy, and we do install 2 systems in the US as well. This is ready to go to market. And when it comes to the biochar value out of sewage sludge, we hardly call it biochar, which is nothing in common with, let's say, woody or lignitic sources. Still, people call it biochar, and I prefer to call biochar from biosolids, biochar from straw, to make sure what the biochar is made of. But speaking of the qualities of biochar from sewage sludge or biosolids, is not structure. The biochar is not creating lots of surface area. Biochar from sewage sludge has like 20, 30 square meters per gram. There's basically nothing. But the nutritional value brought in by the pyrolysis, by the phosphorus, sorry, that is providing some value to farmers or operators. And that can be, given the phosphorus prices on the world market, correspond to a value of, let's say, 100 euros, 150 euros per ton. But this is highly influenced also by the phosphorus price on the world markets, which is only increasing at the moment. The majority still is from the save of disposal.
As my colleague told you, that it's indeed it's exactly what happens. That it's by the savings that you make it sustainable and profitable. In fact, at the moment we are working for a project in US. At the moment we are just installing this pyrolysis system. We'll save about 16.5 million per year disposal of that. And then we're valuing, even if my colleagues say that the CV of the water sludge are very low. Of course, the pre-process, the preparations of that has to be very, very accurate, and we're going to mix that with some other materials like wood chips or something like this. But we have for the project we are working, the char which are going to get out of the pyrolysis will go directly to and be mixed with the materials go to methane. And after analyze, we have realized that the methane productions were up to 40% plus than the engine. So the economy is coming afterwards, and by the product and by the increased productions of the methane after the pyrolysis.
Any other questions? In that case, I have a question of my own. We talked about valorization, and an important part of that valorization would be the creation of carbon credits. Since it's such an important part of the revenue for plant operators. These carbon credits are traded in CO2 equivalents and include a proper LCA, obviously. Jan, with the NGE plants, what would be the typical conversion rate for biochar to CO2 equivalents?
Honestly speaking, it strongly depends on the input material. As in the presentation from Marcel, were shown really good. But at our plant, at the reference plant in Offenhausen in Nuremberg, which converts wood chips, we reach a multiple factor of nearly 3. That is exactly 2.93.
No, I mean, just it's pretty much the same numbers here. It depends on the biomass that we are going to use as a feedstock, but of course that can vary between 2.5 and 3, more or less, is depending on the biomass and the full context of the project. But it's pretty much the same for us. So.
Yeah, totally agree here on the question of when carbonizing wood. What may not the audience fully knows is that you always produce some sort of biochar which has a certain carbon content, and that multiplied with 3.6 is the carbon dioxide equivalent as a potential. What you still need to consider is that the move and the preparation of the biomass, the operation of the system, and basically what happens to the biochar and where is it going is forming as a majority the deductions that are taken from that potential. And these are always project specific. It's individual from customer to customer, from biomass to biomass. And that's why the methodologies are so important to be harmonized and to be, let's say, made correctly. Because it can happen if you are not lucky and you have shitty emissions and you're using coal-fired electricity, that your CO2 potential of grade, I don't know, 3 is common, is completely ruined because you're not having a great integration of the entire system and you're shoveling your biochar from here to the North America or vice versa. And this is very important to understand that the project integration, where are you sourcing your biomass, where is your biochar going, and what is your operation of the system is also an important aspect aside of what biochar to what biomass to use and what kind of technology to deploy.
Thank you very much. Any follow-up questions? Then I'll have a last question. We've talked about a vast variety of input materials. Marcel, you mentioned in your presentation that you see a shift from wood chips toward residue material. And Pierre-Emmanuel, you basically said the same thing, that this is something you're not entirely focused on wood chips. This means we create a vast array of biochars with very different qualities. In order to market these biochars, we have to market them specifically, I would say. How does PyroCore approach this issue?
I think that's the biochar, just so that I would say that the people who need the biochar, and to promote this question of biochar, we have to go through the ISO. That everybody knows there is a regulations. There's a big work which is done at the moment by AT2E, which is a French associations ranking, and you belong to that to these associations as well. But I think that we have to progress in the ISO, so there is some rules, and in particular for us as a, let's say, designer or equipment provider and solution provider, just to be able to define the basis of design according what the client needs, what the market needs, and the ISO for me is the solution for that.
I can't agree more. Standards are super important, not only for the verification of carbon credits, but also for the biochar quality when applied to certain fields or application. And the EBC standard is established for so many years, and it's improving and adopting over time to cover that there's just, maybe not everybody knows, but there's a positive list that covers the eligible type of biomass for a certain application of the biochar. To give an example, we can treat manure, everybody here can treat manure or sewage sludge, but one would not like to feed that to animals and livestock farming. So same with latex mattresses, with ocean cleanup plastic waste. You can carbonize basically everything. It's not the question of what to carbonize. The question is, what was it before, and do you want that biochar going to certain applications or not? And this is why I totally agree that standards and strong standards are very important to protect this young field of subjects around biochar, because there is only one black sheep that can ruin the entire business, the entire industry, with, I don't know, giving poisonous biochar to cattle. Yeah? And this is very important, that the biochar must have a certain quality. And I know so many manufacturers that are really looking at not producing biochar with high PAHs or other organic hazard substances, because that is something the machine controls. heavy metal content in the biochar is something that is provided by the biomass. But process-related potential hazardous substances is typically the organic ones, and your system should have that in control. So please, when you're interested in technology, check the supplier that he has that in control by showing references.
This is a question of ethics as well.
Ethics.
Thank you very much.
No, I think that, and I agree with what you said, but it's also because as industrial, we have to respect ethics, the way we are producing. It's not a question of things. With what we are doing, what we are not ATEX, no, no, it's not ATEX. Can be explosive sometimes if you want to, but at the moment it's ethics. We are industrial. We are there. We are there here just to get this. To fight against the climate change, to reduce emissions and impacts of the humanity on this planet. So of course, if we want to put ISO or rules or regulations or standards, it's because we want absolutely to be at the service as a better world. It's not only an idea, and also we have to understand that we are in a way today where the hydrocarbons, or I would say fossil energy, are going down. The production is going down. So that means that we have a possibility to go to another world with another kind of energy. Because if we want to still progress, we have to all be aware that energy is economy first.
Pierre, I'm very sorry, but I have to cut you short a little bit. We're running out of time. Thank you very much. Thank you to the audience as well. I hope you enjoyed these presentations and the discussions. See you tomorrow.